this video, we're going to talk about missing data and some of the ways we can deal with it in general, and then specifically in RapidMiner. All right, so we get back over to here, and when it comes to doing our data prep, one of the things we need to do is clean our data. Missing data is one of the key aspects of considering what we want to do with that data to clean it. So if we've got missing data, basically we've got null values, and there are a number of fixes. We can just delete a row with null values. If an attribute has too many missing values, on the other hand, we can just exclude that attribute from further consideration. That's going to be something that's negotiated between maybe the data science team and the stakeholders, so just be aware of that. We can try and replace those null values with something that will be useful for us. We don't like to leave information on the table, leave data on the table if we can help it. So yeah, maybe we can just use the mean value, or the median value, or some kind of a mode for the missing value. In general, we don't like to replace missing values with zeros. That's not a good plan for the most part, and it's going to get you in trouble more than it'll help you. Now, we can also try and guesstimate or impute what that missing value should be or is. So this is something, there are lots of different techniques for imputing that value. You can even just regress that feature against all the other features and try and impute it with some kind of a regression equation you come up with. Lots of them are available. As a matter of fact, RapidMiner, we'll see, gives you the ability to create your own imputation method if you'd like. This is generally considered stronger than just using some standard value like the mean, median, or mode. This fourth approach may be good to use whether or not you use one of the other three, and that is to add a dummy variable or an indicator variable that says, hey, there was missing data for this feature in this row of data. That often gives you a somewhat informative attribute in the model, and it's definitely worth considering. And of course, there's no real hard and fast rule. How do we know when we need to drop the feature? Well, some people might say, well, if more than 5% of the values are missing for a feature, then you need to drop that feature. Well, that's super conservative, and you're going to lose a lot of information and potentially informative features by using that approach. More commonly, you'll see more along the lines of 25 to 30% as a good threshold there. But again, you may, in some situations, determine, even if I have 75% of my values missing, that this is an informative feature and one that we need to keep, or again, your stakeholders may make that decision for you. All right, so now why is data missing? So we've got three different ways of classifying missing data, and you can see them right here. Missing completely at random, there's no pattern whatsoever. All right. Imputation methods are useful here, some kind of a replacement approach. Next, we've got missing at random. It seems like that might be the same as missing completely at random, so maybe better would be, like I have parenthetically in the write-up here, conditionally at random, because there is some pattern to the missing data. For example, the example we see here is that there may be more age data missing for females than males. All right. So this is one where you would want to consider the pattern of missing data versus your label variable or even some of your other features to see if there's something systematic in the nature of why data is missing. And then finally, missing not at random. Well, that means that we can definitely see a strong relationship between the missing data and something else. The example here is if we've got some loan application data and one of the fields is months since the last late payment, well, we may leave that field blank unless there was a late payment. So, or maybe the time frame is 7 years that we look back. So it could either indicate that there never has been a late payment or that the last late payment was more than 84 months ago. 0 would not be a good value here because that means, well, their very last payment was late and not even a month has passed since then. So here we've got missing not at random, and in these cases it's often a good idea to come up with a value that conveys the concept or the idea behind there not being a value here in a way that's consistent with your modeling approach. So we could create a dummy variable like we've talked about before, maybe in a regression approach. If we know that we're not going back more than 7 years, we might change that value to 99 or 100, or we could even make it super high like 999. That might be a little excessive, but the idea is that you go well beyond whatever your upper limit is, 84 months in the case of a 7-year look back for last late payments. Okay, so 3 different ways to consider missing data. And then, of course, based on that, we can build sort of a generic activity diagram that walks you through the process of determining which approach to use. Okay, so good little reading there to introduce you to the notion of how to deal with missing data. Unfortunately, it is not a one-size-fits-all solution that would make things nice and easy, is it? All right, so let's go from there and jump into RapidMiner and see how we can deal with missing data. In this case, I'm going to use the lending club data. And one of the first things we might want to do is just take a look at some of the data quality measures. So in the cleansing folder down here below the other subfolders, I've got one called quality measures. So I can actually just drag that up here, run that through, and see what quality measures I have for my various features. So I've got the attribute name. How much like an ID is it? So the higher the number, the more unique it is for each individual. So you can see employee title is very much like an ID. The total current balance, so that's going to be maybe fairly unique for every individual. So ID-ness, that is something that's worth keeping an eye on, and RapidMiner sort of gives you that measure along the way. The more unique something, in machine learning, we generally want values that are somewhat unique, enough to differentiate, but not completely unique for everyone. So we don't want everybody to have the same value for a feature, but we don't want everybody to have a completely different value for a feature either. Stability just basically is a measure of how many values are real similar to or actually the same. So this one here, accounts now delinquent. Well, hardly anybody is now delinquent in this data file, but we do have, looks like 0.3% that are. So that's a very stable feature. All right. How many missing? Okay, well, that's pretty self-explanatory. How many are missing? Most of these don't have missing. But we also have this one here, months since last record, and that would be some kind of a negative record against them. Well, 84% of those are missing. Months since last delinquent, 51.4% of those are missing. So that is a useful figure. And then textness is one that basically says, well, how similar does this look to just unstructured text? So the loan status, well, it's a word. Purpose, purpose is a text field. Home ownership, grade and subgrade, well, both of those have letters and number combinations. So the textness is fairly low on all of these. And then the loan status does have specific words, but it's just classification words with, I think, 6 or 7 different values that the loan status can take. All right. So this is one way to take a look at just some quality measures of your data. And of course, we can always take a look at the statistics here and see some of the same things. For example, I can see the least most common value of loan status and the most, and then I could also see what all the potential values are. Well, there were 6. So current, fully paid off, charged off, late, in grace period, and then late again. So this is in order of how many there are, what the fraction is. Okay. Then, of course, loan status numeric. We're going to have similar, but it's a numeric version of this. And I can also see how many missing values, how this is going to be a count for each of these. So months since last record, that was about 51.4% if I remember. And that's 8,816 of these. All right. And in the data, we had 10,492. All right. So quality measures, you've probably looked at your data in Excel as well to calculate things like skewness, kurtosis, etc. Okay, so now that we've taken a look at the quality, we can get into the nitty-gritty of dealing with missing values. Months since last delinquent. Let's take a look at that one. We have 5,391 missing. So we'll go into our cleansing folder here, open up the missing, and say replace missing values. So when I put that up, yeah, that's connected. Now in the parameters for replace missing values, I can choose how I want to replace them. It defaults to all. I can do just one of the parameters. I'll choose a subset, and let's select months since last delinquent and months since last record. Okay, so I'll apply that. And then down here, I can tell it what to replace with, and I could have it replace with the min, max value, an average or mean value with a 0. We know we don't like doing that, and certainly that would not be useful for these two at all. Or I could replace them with a specified value. So when I select value here, I could put what I want it to actually be replaced by here. Now, 84 is the number of months that we're going back. If we type in 84, that says, well, then they did have a negative record 84 months ago. And we're right at the end of that. So we don't want it to be 84. Do we want it to be 85? Which indicates, well, they did have a negative record, but it was just outside our threshold. So maybe still worth keeping on the radar. It would be better to make this a number that is obviously well beyond the scope of the general range of numbers we're going to be dealing with. So let's just say 120. Okay, so instead of 7 years, we've got 10 years. And you could go, wild and say 999 if you want. But generally, you want to have at least a decent sized gap here. So now when I run this, you'll see that months since last now has a lot of 120 values for both of them. If I go to the statistics, that's probably going to be it's my max value. And it's also my mode value. Take a look at that. So it changes the distribution and gives me a big, wide, or a big population up there with that value. Now, because we know why we did this, that's okay. All right, so that's replace missing values. And of course, you saw some of the other options. I can impute the missing values. To impute missing values, we will drag the operator up here, And you'll notice that it has kind of a layered box look to it. What that indicates in RapidMiner is this is an operator that actually hides a subprocess. So I can build my own process within this operator and then feed the results of that out to the rest of my process up here at the main level. So let's see how that works. First, to impute the missing values, I need to tell it which features I want to use for calculating these missing values. So we're going to keep it fairly simple. I can make it as complex as I want based on how much processing time I have and how good I want my model to be. So let's say we wanted to impute employment length. We know that has a fair number of missing values. And let's take the income. Let's see, where's income? Annual income. So we'll bring that in, and let's use revolving balance and revolving utilization as additional numeric measures to figure out employment length. All right, let's see how this works. So I'll apply those, and I'm going to use those 4 fields together, those 4 features. Now in here, I can choose what mechanism I want. I can just create some calculations to create a calculation between these fields, or I could actually model this if I wanted to. So let's give that a try. Let's go into our modeling. We'll do a predictive model, and let's use a nice easy one, K nearest neighbors. We've discussed that in the past. That's a pretty easy model to use. I'll connect the output, the modeling output, to my output port there. So let's do it with, let's just do the 2 nearest neighbors. We're going to do this real easy. And we can leave mixed measures, mixed Euclidean. Okay, so now I go back up to the main level here. And remember, in Lending Club Small, for employment length, I had 732 missing values. So let's go ahead and run this. It'll take a few seconds to run. We'll see what we get when it's done. Okay, so it ran about 40 seconds. And we come back and I look at my statistics and I can see down here, employment length, I now have no missing values. If I go back and look at my data, employment length, yeah, so we filled in one of these values for every missing value based on a nearest neighbor's approach. So imputing missing values. All right, let's move ahead and see what we can do next. Now we know sometimes we'll just remove the row that does have that missing value. So in that case, we can use a filtering tool. Let's see where that would be. Okay, so I can use a filter examples, and that's back up in the blending folder to remove missing values. So here I will say add a filter. So let's set the filter. I add the filter, and I only want to keep those where employment length is not missing. Okay, so I don't have any value that I need to put in here. So I click OK, I run through that. And now you can see I have 9,760 rows of data. So I filtered those 200 some odd missing values from employment length out. So I just took those out completely. Now, in some cases, if we determine that too many values are missing within an attribute, we can just remove that attribute entirely. So for this one, we're going to go down into our extensions and in the operator toolbox, and I believe it's in blending. And yes, down here we've got filter attributes with missing values. So if I bring that in here, I can choose from one of the methods. Well, I'll keep it if there is any non-missing data, one or more non-missing data, keep all. And then I can specify, well, what is the maximum number missing or the maximum relative number missing? So if I say relative, and of course our very most conservative might say 0.05, but let's go with our 0.35 that we've discussed, which is relatively liberal, but that should allow us to remove at least one or two of our features that do tend to have a lot of missing data, and I think that's the months since. So let's run this and see what happens. Now remember, we had 35 features before, and now we only have 33. So what got removed? Well, let's see. I'm pretty sure it's going to be those months since. Let's go back and see. Yeah, let's see what the results tab gives us there. We'll run it again. Okay, so here's our new example set after filter those attributes with missing data. 33 features. Oh, and this is just the original data set passed through. That was the ORI. So we could see we had, let's see, where is the months since? So it's right after inquiries last 6 months. So let's see if those are the two missing. Yeah, inquiries last 6 months, and then we go to open accounts, which, yeah, that would be the next one here. So months since last delinquent, months since last record get removed. All right. So we've got a number of different ways to deal with missing values. These are just a couple ways you can do that. So I hope you found this helpful. Let's get back and see what we'd like to do next.